Hello, students. So here is the video lecture for the next chapter. This time round, we'll be looking at mensuration. This is part one, right? So as the topic suggests, mensuration simply means the study of how we measure things, right? So in mathematics, we measure lots of things like perimeter, area, volume, etc., etc. And they help us to solve a lot of issues, real life issues, such as optimization problems in two-dimensional, three-dimensional spaces, and so on and so forth. So to be able to measure things properly is pretty important. And the first thing we want to understand is how do we measure? So since the dawn of humanity, different civilizations actually have their own way of measuring stuff, and it gets very complicated when people start to interact with each other. Hence, some years back, right? So the scientific community actually came together, and they devised this international systems of units, sometimes shortened to be called the SI units. I'm very sure you have already been exposed to this in your science lesson, so I will not actually dwell too much time into it, but suffice to say that SI unit is pretty important, and nowadays we all adhere to it, right? And it's really helped with a lot of communication of ideas, of measures, a lot easier. So sometimes we have the SI units, and sometimes we need to actually create new units derived from the SI units. For example, here we have a length. A 1 meter is actually meters, right? Measuring length is actually a SI units. But when we want to find the area, when we find the area, we tend to use square meters. So where the square meters come from, we actually multiply with a length with another length, right, to get an area. And so square meters is actually known as the derived area. So we also tends to actually work with derived area quite a lot in mathematics. Okay, so that's a little bit of introduction to you. So some of the big ideas here, right? Numbers are used to quantify real world properties or mathematical objects, so that we can analyze and compare this. So the SI units, there are actually 7 base units. So over here, some questions for you. What are the 7? And know whether they can take positive or negative values or zero. I'm not going to spoon feed you with the solution here. These are information that is quite easy to obtain from the World Wide Web, the internet. So feel free to read up on them, and I encourage you to read up on them. It's good to actually have a good picture of what's going on, right? So and of course, what are the advantages of actually using all these standard units? I'm sure you can on your own capability, go and figure out what are the best solutions, then write a couple of reasonable ones in your notes. There's your handout that is accompanying this video lecture. Okay, so this introductory problem is something that to show you how measurements of area and length is very 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 commonplace, and we use them in a lot of real life situations. So imagine you sometime in your future, you may actually want to buy a flat of your own, right? So you need to plan out all your furnitures, your flooring, your tiling, how you're going to work it out, and then talk to your contractor, how you're going to renovate your house. So it's actually good to have a good sense of this. So this one we can actually talk about in person. So let's move on. I'll just actually go on to the important points, right? So of course, the first thing we need to know is that sometimes we use prefix. Like for example, we are familiar with centimeter. So centimeter is not exactly the SI unit. The SI unit for length is actually meters, but we add the prefix centi to actually help us, because using centimeter allow us to measure length that are pretty small. For example, the length of the pen you're holding in your hand right now, of the length of the screen, etc. Right, you don't always want them in meters, because sometimes we don't want to deal with decimals if we can avoid it, right? So prefix become very useful, and some of the common prefix, I'm sure we have already touched on them. You have learned them in primary school, you're now in secondary school, so you should be familiar with them. But in case you need help, do look for somebody to ask. You can come and look for me, I'll tell you about all the prefix, right? But what we want to deal with right now is that we are actually quite familiar with the conversion of units based on the length. But how about area, right? So here are a couple of practice questions just to kickstart and get used to the idea. So the first one, what we want to do is we want to convert 40 square meters to square centimeter. What can we do? Well, I mean, you can memorize how many decimal places to actually move your decimal point, or okay, a more practical way is we can recognize the fact that we can break this 40 square meters into a certain length times a certain length. It's quite similar to the idea of prime factorization, which we have learned earlier this year. Okay, so for example, in part A, I could actually do it in this way. I can write down 40 meters, right, and then square here. This is actually the same as 4 meters by 10 meters, right? I can actually break them down in this way. And if I want to convert them to centimeter, this will be 400 centimeter, right? By, down here we have 1,000 centimeter. So I put them back together, this will be 400,000 centimeter square centimeter. There, okay, so that's one way we can do it very practically without trying to memorize all the different conversion. I just need to know the conversion of length, which I've already learned in primary school, and then apply them accordingly to area. Okay, so once you get an idea very quickly, okay, you can actually fill up the rest. You can try it out yourself. You can pause this video, of course, and try it out yourself. Then after that, you can unpause it and compare your answers with mine, right? So let me just use a different color pen so that, you know, on your screen is clear. Okay, so feel free to just carry on. So here's 0.03 square meters. How do I deal with this? Well, I will put this as 3 meters by maybe 0.01, right? You can, of course, you know, use other combination like 1 meter by 0.03 meters. Why not, right? It works as well. So here 300 centimeter, here will be 1 centimeter, and that result in a good 300 square centimeters, right? So let's convert the color again. Part C, now we have 16, so 16 square centimeter. What I can do is, this is 4 meters, sorry, yeah, 4 centimeters by 4 centimeter. I can do that, right? You can also do 1 by 16 or 2 by 8, they work fine. Okay, so this give me 0.04 meters by 0.04 meters, and then use the calculator, put them back together, you'll get 0.0016 square meters, right? And of course, the last example there, okay, using the same idea, we have 28,000, right, square meters. We can actually break this one down to 28 cm by 1000 cm. Why not, right? So from here we have 0.28 meters by 10 meters, which give me the final result of 2.8 meters square. So you get the hang of this. I hope you are. It's not too confusing. So using the same idea, we can apply to volume as well. So in the next section, let's take a look at volume. So let me change the color of my pen so that it looks clearer on your screen, right? So we have 4 cubic, right? Now I talk about volume. So in the same using the same idea, I can actually write this as 4 meters by 1 meter by 1 meter. Okay, that will give me 400 centimeter by 100 centimeter by 100 centimeter, right? Put them all together, we have 400,000, right? Get the number of zeros correct, try your best, right? And there we go. Okay, so part B, what do we have for part B? Part B, we have 0.5 cubic meters. Let me write it properly. So I can actually break them down into 0.5 meters by 1 meter by 1 meter, right? Converting it to centimeter, we have 50 centimeter by 100 centimeter by 100 centimeter. Put them together, we will have 50,000 cubic centimeter. You see how it works? All right. So a couple more examples. Okay, let's write it here. So part C, we have 250,000 cubic centimeter. Okay, I can break this down into let me see, maybe we try 25. Okay, 25 centimeter by 100 centimeter by 100 centimeter. Now there are a lot of different combination you can use, right? As long as your combination is correct, you will get the same result. So here I have 0.25 meters by 1 meter. I mean, I like the 100 centimeter because it converts to 1 meter beautifully. So that results in 0.25 cubic meter. All right. So one more example. Again, I'd like to remind you, if you want to try these questions on your own, feel free to pause the video, try it out, then after that resume the video and compare your results to see if you have been successful. I think that's a great way to learn. All right. So next one, we have 67800 cubic cm. Okay, so I can rewrite this as 678 centimeter by 10 centimeter by 10 centimeter. Why not, right? This is a combination that works. So 6.78 meters by 0.1 meters by 0.1 meters, and that will result in 0.0678 cubic meters. Okay, so that's the first part of this chapter, which we want to refresh our memories on how to actually do conversion of measures properly to get the derived units. I hope you have been successful. I now see you for part 2. Have a nice day.